Viola.
The most random tangent ever. Hello and welcome to the HACKADAY podcast. I'm Elliot Williams.
And I'm Kristina Panos.
This is episode 244. This week we'll be talking fake chips, drinking radium, and spotting slippery neutrinos. I learned something new today, and that is the solar conjunction. And that is when the sun gets in between us and Mars. And one of the things that has to happen during the solar conjunction is that they have to shut down all of their Mars rovers because they're not going to get to talk to them for about 2 weeks because the sun is very big and makes for messy radio communications. And why am I saying this? I just thought it was neat and thought you might want to know. If you have your spacecraft parked in orbit around Mars, you're not going to be able to talk to them for the next couple weeks. So, just relax or something. It's a great plot device for a sci-fi piece where, there's a colony on Mars and they drastically need to get a quick message back to the Earth, but they can't do it because it's during the solar conjunction.
Oh, dear.
Right?
What do they do? What do they do?
Exactly. I don't know. It's just a plot device. The rest is up to some writer who's cleverer than I am. I'm not a very good creative writer, I'm afraid. I write HACKADAY. I don't write creative or something.
I try to, but I can't do genre stuff.
No? What do you do?
It's, I guess, slice of life. I don't know. One of them is historical fiction if you consider 1978 to be historical at this point.
It's getting more and more historical every year.
That's true.
It's like, what is retro computing,
Yeah. That's funny. We went to an escape room.
Okay.
Our first time in an escape room, and it was all about intercepting this signal from some evil people. Part of it was we had to put all these laptops in certain places and then do stuff later on with them, and they were all so old and heavy. And no batteries in them either. And they were, oh man, it was just funny to play with old laptops again. Was
it meant to be old? Was the fact that they were old part of the deal?
Not really. They just they needed so many, and I assume they didn't want people to be tempted to take them.
Right. They weren't going to use their good laptop.
No. But they had all these other old, one of the computers that you actually use had a monochrome display.
Oh, cool.
Yeah.
Oh my God. I've emulated a monochrome display lately.
Fake? Maybe it was fake. I don't know. I was pretty involved in trying to get out of that room because it was just me and my husband, and it was supposed to be for up to 8 people.
Okay.
Because there's a lot of running back and forth, it turns out.
Right.
And you're not supposed to use your phone.
Just the brains you brought in with you.
And maybe a pen and paper if you remember to bring that.
Right.
If you have to have that on you.
I'm talking to you, so you must have gotten out.
Yes.
But I have to ask anyway. Sorry, can't do the podcast stuck in an escape room.
Oh dear.
What happens? They must let you out eventually.
Yeah, well, we actually solved it, but we were negative 2 minutes on time.
Oh, boo.
Yeah.
Nice.
And then the guy came through the wall of motherboards that looked really cool. It was all these motherboards on a wall.
Okay.
And they drilled and had LEDs through them, and it was just all blinky and looked like a crazy server room, sort of.
Right?
It was neat.
That sounds pretty fun, actually.
Yeah.
Good time?
Yeah.
Are you ready for What's That Sound?
This is a journey into sound.
What's that sound?
What's that sound?
You tortured me with one last time, so.
But so many people got it.
That was a great one. I was surprised so many people got it. That was a super one.
Well, I'll try to think of more.
Yeah, please
Or
do.
happen upon more.
Well, I tell you what, I cheesed out this week. This is a sound from Chris Lott, who sent one in. So one of the other HACKADAY writers is doing this to you.
Okay, I'm ready.
Go for it.
Here we go. I want to say it's a hole puncher.
It's not bad. It's a similar device, but think nerdier.
Nerdier than a hole puncher.
Well.
Oh, to punch for punch cards.
Oh, that would be awesome. No, it is not.
Okay.
That would be super awesome, though. Man. No, it's I don't know. If you don't have one of these, you maybe don't know it. Once he said what it was, I absolutely recognized it. But I'll admit I didn't know it at first here either. But I actually have a pair over there in the corner. It's
Oh.
Chris claims that he calls them kerchunkers.
Well, what else are you going to call them?
Exactly. So good luck to you all out there. If you can guess what this sound is, head on over to hackaday.com/podcast. Fill in the form and include your best guess, your handle, and your email. And if you get it right and we pick you next week, I'll get you a Hackaday t-shirt in the mail. All right, well, let's talk some hacks.
Okay.
I want to start out this week with D-Point, a digital pen with optical inertial tracking, which is a really cool project by J.C. Parkin. And what this is it's, the electronic pen of the future. You can write with it on a piece of paper and it translates everything back to your computer. And it does so by having an IMU on board so it can, feel when you're tipping and moving the pen. It's one of those with accelerometer and gyro. It's got a force sensor on the nib so it can tell when you're pressing down and actually even how hard you're pressing down, which is kind of a neat extra degree of freedom for the stylus.
Oh, yeah.
It's also got some of those like quasi QR code like things. These are Aruco markers, which are meant for computer vision orientation and stuff, and uses a dead stock regular old webcam and some good OpenCV processing and stuff to figure out where the top of the pen, it's like what would be the eraser if it were a pencil, where the top of the pen is in relation to the camera. And it's really cool because the IMU and the force sensor are kind of enough to do pen, but because they're slightly noisy measurements and because, you're going from an acceleration, you have to integrate once to get velocity and you have to integrate again to get position. There's a lot of error in that system. And so it uses the relatively slow updating and kind of computationally intensive stuff coming from the webcam to keep it in basically the right place, but then uses the accelerometer data to handle the kind of fine movements in between. And it's a really cool project because it kind of leverages a whole bunch of stuff that's cheap and easy these days, like an accelerometer and a webcam and a little bit of processing power on your computer. It's a nice 3D printed case. It's actually something you could make at home, but the programming of the processing done on the back end is some pretty clever and complicated sensor fusion stuff, which makes it work. And I think that's really awesome because none of the hard stuff is expensive. Like all the hard stuff is in software and is essentially free. All the stuff that you would need to buy to implement this yourself and play around with it is free, cheap, and or easy. And actually, if you head on over to the GitHub page, which all you listeners out there should do, J.C. Parkin has a video of using the thing, and you can see how it works with both. This is one of those things where whether it's done right or not will make it smooth or unpleasant and jerky. And watching it in action, you can kind of tell that this is it. This is the project done right.
You can really see that pressure sensor in action, I feel like, because it looks like you're using a flexible point pen.
Yeah.
Especially on the P and so on.
Isn't that awesome?
Yes, very much.
This project was part of my undergraduate thesis for electrical engineering. I hope you got an A on this. This is an absolutely superb implementation. So, kudos. And while I'm on the kudos, project is fantastically documented. Exactly what you'd hope for in a project if you wanted to reproduce it yourself too. Plus, you might learn some cool math. If you're into that sort of thing.
Well, my first hack is Virginia Cave is the largest musical instrument in the world. Well, this is called the Great Stalacpipe Organ, which of course is a portmanteau of stalactite and pipe organ. Now, technically it's not an organ, it's a 37-note percussion instrument, but who's counting? It's played like an organ, though it is technically a lithophone. It can be played by a player or it can run like a player piano, and the mechanism for that, which they show in the video, is pretty cool. I don't know about you, but if you've ever been to a cave, they don't exactly want you to touch anything. But
Yeah.
apparently that wasn't the case in the 50s
Yeah.
because, because the guides were into tapping the stalactites to demonstrate that different ones gave off different sounds. So this Leland Sprinkle just took it upon himself, hopefully he got permission, to angle grind off a bunch of stalactites to make them sound like he wanted to, and to build an instrument out of them. And it is the largest instrument in the world because the caves are 3.5 square miles or something like that. 64 acres, excuse me.
Yeah, pretty darn big.
So yeah, so it made me think of the Zadar Sea Organ again, which I forgot why we talked about that last time. Some other big instrument.
I put it on What's That Sound once.
Oh, you did? Oh, that's right, that's right. So I will put a link to that and also to a video because the link doesn't have a video of it.
I've actually been to Luray Caverns when I was a kid. I don't remember the organ at all.
Oh,
I've been to Luray and I've been to Rock City, both, which are, I grew up in Tennessee, round about Nashville, and it's like the whole place is filled with caves. If you dig down, it's like playing Minecraft. If you just dig down a little bit, you're in a cave all of a sudden. It's pretty crazy. So I grew up with caves, and when I was a little kid, went to Mammoth Cave, which is either the largest or the second largest cave system in the world, depending on who's ahead. There's a team in Mexico and there's this team in Kentucky with Mammoth Cave, and they're both like continuing to map their caves out, and they like one of them takes the lead for a while and then the other maps out some more, and then theirs is the biggest for a while and then the other does. Anyway, cave trivia.
cave leaderboard.
Yeah, right? But man, Luray and Rock City are both kind of tacky. Like they're definitely like 1970s cave aesthetic or something. So I totally can believe that they would do this. On the other hand, it sounds really, really cool. So I think it would be awesome to be down there and, like in the organ, whatever,
Oh yeah,
it has to be playing all around you, right?
yeah.
Like, so you get some notes from off to the left and some notes from off to the right. That has
That
to
would
be
be
a
cool.
really weird, echoey surround sound experience, right? Yeah, anyway, there's a whole ton of incensed cavers in the comments who are like, don't touch the drippies. Be- because, of course, if you get your oils on it, it prevents the further calcification and it stops the stalactites from growing. Probably forever. So these are probably all, completely dead stalactites now. On the other hand, cave's got how many of them? Cave like Luray has so damn many. If you chop up 37 and tune them up, that's a drop in the ocean, I guess. It's still wrong, but it's not very wrong. I guess. I don't know. Caver aesthetic in me says, oh my God, don't do that. But crazy musical instrument aficionado in me says, oh, that's really cool.
Won't someone think of the stalactites?
My next pick is Denki Otaku. Cheap power supplies with fake chips might not be that bad. This is the story of those deadly cheap Chinese LM2596 in quotation mark buck converters. So these are voltage regulators that step down a DC voltage from higher to lower and kind of sort of regulate it. And the chip in them is an LM2596, which these days runs about $5. And so it's an interesting question how you can buy a board already populated with these things for about $1. Right. You know the answer. The chips are fake. And he goes through testing all the parameters and, discovers that he's got fake chips. It all starts with like the horrible silk screening, and he buys like a bag of 10 of them, which I will admit to having done myself. Tremendously useful to have these things on hand, and notices that like even the fonts on the chips are different within his random bag of 10 of them. Ooh. And then they have different pins, and the heat sinks all have different shapes and everything. Like they're just completely bad knockoffs, and they're not even consistent among themselves. Worse than that, I think, is that they don't run at the higher frequency of 150 kilohertz that the LM2596s are supposed to. Instead, they're kind of sitting around 50 kilohertz. These are switching buck converters. So they let a little bit of current into an inductor and then shut the switch off. That bleeds out slowly. And then they let a little more in and shut it off. And that bleeds out slowly. And so that's how you go from 25 volts on one side to 5 on the other, is by just kind of being on only a fifth of the time and using the inductor to smooth it out. The frequency you do this with, so the faster you can turn that switch on and off, of course, the less ripple you get and the more responsive the thing is to, transient loads and stuff like that. And what he finds is absolutely horrendously horrible ripple on the output of this thing. I wrote in my notes, "Holy ripple, Batman," because we're talking 400 millivolts when he has it set to 5 volts. So kind of 10% ripple on top of the voltage, where kind of, you kind of want 1%. So they're kind of crappy. That said, it's a buck. What do you expect? And for a buck, they're actually pretty useful. And like Denki Otaku concludes, I've got a bunch of these in my closet. I use them all the time. They're totally fantastic as a variable. They also sell them in boost configuration and in boost buck configuration for only a few cents more. The chips are counterfeit as all heck, but the boards and modules are really very useful. He feels bad for liking these things, and I guess I kind of share that. They're only so cheap because they're obvious fakes, but it's kind of nice to have a cheap DC-DC power converter on hand when you need one. But if you do get into these, you had better derate it. The real parts are not only provide a cleaner signal, but will give you like 3 amps of outputs. And when he tries to get 3 amps through this thing, it gets up to 115 C, and he like visibly burns himself when he tries to pick it up. So yeah, warning, probably sticking around 1 amp on the output is going to be your best bet. Be careful if you're trying to step down from like 25 volts to 5 volts and pull a big load through it, like to drive a Raspberry Pi or something, you're gonna get burned. like literally. And what's more terrifying than burning power supplies?
Oh, I would say radioactive water being sold as some kind of medicine.
Oh, that sounds horrible.
Yeah. Well, that brings us to my next hack, which is Adam Blumenberg's presentation on Radithor. The title of this one is "Radioactive Water Was Once a Horrifying Health Fad." Boy, is that true. So the name comes from radium-226 and mesothorium-228. And if I may nitpick, I'm not sure why it's not called Radithor instead of Radithor, but whatever.
Maybe it is.
Adam pronounces it Radithor. Tomato, tomato.
Radithor.
So a guy named William Bailey is the con man behind this one. And Adam Blumenberg actually gets into his past and finds out that he dropped out from Harvard. And he had other sham medicines, including a male enhancement product that contained strychnine.
Woohoo!
So this stuff was advertised as harmless, and it was even prescribed by physicians, but it took the death of a celebrity to give people pause about it, in spite of the whole Radium Girls thing, which had happened just a few years before. So these are the girls who painted the luminescent dials on watches and clocks, and they needed a very pointy tip on their paintbrush so they would lick the tip. And you can imagine what happened there. So yeah, so the moral of the story, the end of the story, is that it helped inspire the Food and Drug Act of 1938, which has no doubt saved a lot of people since then.
What I thought was super creepy about that was before that act was passed, and Adam talks about this in his talk, is that the FDA was powerless to do anything against this because it claimed to contain radium, and it actually did. It's not like it's tricking anybody into thinking it's anything other than it is. And at the time, the FDA was only able to stop people from like misrepresenting the medicine. And here he was saying, oh yeah, it's diluted radium, go nuts. But then he claimed, of course, that it did all of these other beneficial things like you do with quack medicine, right? It's got to cure 6,000 different things. Yeah, oh, that's so horrible. Ugh. Although I have to say, the radioactive jock strap that this Bailey character also sold is probably the worst thing I've ever heard. The idea of strapping a radioactive source next to the most radioactive sensitive part of your entire body is just so bad. I can't even say. And that's, yeah. When radiation was new, there were all these dumb ideas, but this is 20 years past that. This was when, like you say, it's past the Radium Girls episode. This was when you really should have known about it.
What was that thing they tracked? They lost it and they found it on the side of the road.
Oh, Lewin wrote that up.
Yeah.
Yeah, that was like a cesium source for something.
Yeah.
And it fell off the truck that it was on, but they were able to track it because it was hot enough that they could just drive by and their Geiger counters went beep.
Should I link to that on the...
That's a great story.
There we go.
Lewin's article is the one where I learned the way they label highly radioactive sources with the phrase drop and run. And you know, if you see something that says drop and run, I mean, if you don't know yet, if you ever come into contact with anything that has things that look like skulls or radiation signs on it, but in addition says drop and run, it's not a joke. Drop and run, and then call. Well, speaking of horror stories, does getting into your garage really need to be difficult? Is a story that Dan Maloney wrote up about the Chamberlain Company, which apparently has about a 60% market share of garage doors in the United States. For a while now, you've been able to integrate these garage doors into the incredibly popular Home Assistant home automation system. That, of course, lets you tie your garage door to everything else, and you can figure out if it's open. You can have it send you messages. You can open it remotely. The whole darn home automation thing. Home Assistant, if you haven't played around with it, it's really super. I don't use it, but I've played with it. It's really pretty darn cool. This is the sort of thing that you want your home garage door to plug into. Chamberlain decided that they wanted to take their toys and go home. You're only allowed to use their MyQ phone app with it, and that's because they want to be able to show you advertisements and lock you into their platform. And boo.
Yes, boo.
And this is exactly the sort of technology monopoly over-grabbing that Cory Doctorow called enshittification in his keynote speech that he gave just a week and a bit ago. And this is like exactly, you should go watch that talk. It's really hilarious, but it's also contains more than a kernel of truth, unfortunately. And that is that tech-based monopolies seem to be able to get away with murder because the FTC isn't very willing to enforce against tech monopolies for whatever reason. I guess because it's tech, right? It's confusing. He makes the case that they absolutely should, and this sort of behavior, i.e. you can't control your own garage door however you want to, is horrible and anti-competitive and just miserable for the consumer. And what I really liked about this talk, actually, is that he proposes two ways, a two-pronged approach to getting our way out of this. And one of them, of course, is, and I think it's absolutely necessary, kind of legal/policy action. So getting the FTC to enforce antitrust claims like this obviously is. So, bring in the law on them. But the other method he suggests is kind of the hacker method, and that is that we write compatibility layers anyway to make it work with our things. And that's what's actually happening with the Chamberlain story. And so if you read down in the comments, it's actually kind of cool. And if you read Home Assistant's position on the whole thing, they mention that there's an open source, in kind of air quotes for the moment, project called RATGDO or RATGDO or something. It's a hardware solution with open source firmware. If you look at the board, it's really nothing more than a breakout board for like an ESP8266. And so someone else, Caldec, has an open RATGDO board. And basically it's like you expect, it's an 8266, 2 MOSFETs, 3 resistors. There's like nothing to this thing, but you wire it in directly to your Chamberlain door opener. And then you get the keys to the kingdom and more. You get not only what you would have gotten through their app, but some more detailed control over the garage door opener as well. And you can use it with Home Assistant. So Chamberlain is trying to screw you. You can either wait until the FTC takes action, or you can take matters into your own hands. You are the hacker. You build the interoperability layer, and you put it to the evil company. That's what I liked about the story, is that it's horrible behavior on the part of a monopoly garage door manufacturer, but then it's also our folks striking back and liberating them.
Well, on to something more lighthearted.
So far we've gotten radiation poisoning and and monopolies behaving badly. Let's go.
Okay. My next hack is Becky Stern's 3D printed stamp rollers. If you've ever used a stamp roller, they're kind of fun for making borders and stuff. You just roll the pen along, and it self-inks because every revolution it rubs the head of a pen or something filled with ink. Becky's friend Moxie wanted to know if she could make bigger custom ones, and Becky's like, "Of course we can." So she 3D printed a special cap and started with a fat-barreled Sharpie, and those have an angled tip, so she cut that off flat, but she didn't really want to have to use those, or have to do that every time. So she managed to find an acrylic pen with a square tip and use those instead, and it's actually kind of the same size. I'd be surprised if she had to mess with the dimensions of the cap too much between the two pens, and then she started using them, and it worked better than the Sharpie. But she studied the ones she already had, the commercial ones, and found that they had like extra elements in the design. Because some of the ones Becky made were just like a line of stars, but if you add like little dots in the negative space, they come out a lot better. They work a lot better.
Yeah, because it's like if you just print out a bunch of things on the edge of a cylinder, it's not a good wheel, right? It's like a square wheel. It's like goes ka-chunk, ka-chunk, ka-chunk.
Yeah.
So you kind of have to even it out a little bit. Yeah. I'm watching the video right now live. That's pretty cool.
Nice. And she ended up trying all TPU, but that didn't work very well because it wasn't the sides of the cap weren't strong enough. So then she tried a PLA cap with a TPU element in it, and that works pretty well.
That makes me want to make really giant ones and do like wall graffiti or something with it.
Ooh.
I wonder if you could even do it with water or like a chalk paint or something. So it wouldn't even be permanent, but you could, just roll it along. Yeah, no, now I want to make a huge one. Now I want to make an absolutely gigantic one that I can give to a kid.
Will it have the Jolly Rancher?
Oh, that's a good idea. Oh, that's a really cool technique.
Ranchers everywhere.
My first quick hack this week is solder 2 boards at once with this dual reflow plate, a project from Michael Ben. When you have small boards, you don't want to heat up the whole surface, and when you have big boards, that small reflow plate isn't going to be big enough. His solution is to take 2 reflow plates, jam them together. What I thought was cool about this was the off-the-shelf heater element he got that I guess is meant to be used as a buffet warmer. And if you read the reviews on Amazon, they're all negative because it's a crappy buffet warmer, except for a few of the reviews, which are from people using these 2 hot plate solder things, and they give them 5 stars. So,
nice.
Yeah.
That's the one.
Next up, Adam Herrig putting 3D printed screw threads to the test. Adam wants to use 3D prints to suspend a camera and wanted to make sure that the threads were strong enough to hold before he put it on there. It fell to the ground and broke. So he tests 3D printed screws into 1/4 inch, that's kind of 6mm, American threading, like the ones on tripods, at different infills, 10%, 25, 50, and 100%, and finds that they hold 50 pounds, 70 pounds, 90 pounds, and more than 110 pounds, because that's where his scale bails out, respectively. And all of these are factor of 2 more than his camera holds. So he's not worried about using just straight up screws into 3D prints. I've done this for years. I'm not worried about it either. But it's super nice to see the numbers. Next up, Sebastian over at Baltic Lab NeoPixels? Question mark? Try liquid nitrogen to color shift your LEDs instead. This is a cool physics experiment demonstrating that LEDs change color when their temperature changes. And if you've ever like burnt out a yellow LED and watched it go orange just before it dies, you know what we're talking about. Here he's dipping yellow LEDs into liquid nitrogen to turn them green, and he pulls it back out and you can watch it slowly turn yellow again as it warms back up. It's a cool experiment, little bit of physics. And last up, this does not compute leaky SMD electrolytics. Try these brute force removal methods. This elicited great responses from the comments about how to remove surface mount electrolytic capacitors that have gone bad. The common tier consensus seems to be push and twist when you're taking it off instead of pulling, and you won't pull the traces up off the board. This does not compute tries cutting off the top, hot air, and desoldering tweezers. And I guess no surprise, desoldering tweezers is the professional and awesome way to go. But other people swear by just going in with a pair of side cutters and cleaning up the leads and whatever electrolytic gunk is left.
My first quick hack is Mr. Innovative's Arduino sticker dispenser saves time. Now, although it may be true that these kind of fragile labels make shippers dropkick your package across the distribution center, they might actually do some good. But if you have to sticker a ton of boxes, you might want to build yourself one of these, because it's a really tidy build. It's very small. There's nothing excessive to it, and it even handles its own waste because it rolls it back up on another roller. It's made of it's really just extruded aluminum, 3D printed parts, and smooth rod. It's very cool. Next up is Nikolay Valentinovich Rybnitsky's forever writing on monofilament fishing line. Now this may not last as long as intended, but it's still an interesting idea. You probably know that we have a problem with maintaining information records over long periods of time. So Nikolay's idea was to use plastic, which doesn't break down very fast, if at all. Basically, it takes fishing line and feeds it into this machine, and it makes little nicks on it that represent ASCII characters. But hopefully it lasts as long as he thinks it will. Lastly is the scientist formerly known as Nagelli's hack a soda can to jewelry. Now this is quite the process to take 2 soda cans and turn them into a really cool necklace. But the result is very nice, and possibly sharp, hopefully not sharp. But first you remove the paint from the soda cans, which apparently the scientist formerly known as Nagelli was the first to discover this process of using a pressure cooker and then nail polish remover, which, if you don't know, most of them contain acetone, so it's mostly the acetone probably doing the work. And then to make the necklace, used a special strip cutter of their own design that sort of resembles the ones you use to cut up plastic bottles, but it's a little different. I thought it was interesting that, and it makes sense, that you have to, once you wrap the strip around the rod to shape it, you have to cook it in the oven to make it set so it doesn't just lose its shape.
All right, well, that brings us to our can't miss articles. These are long-form pieces written by our fantastic HACKADAY writing staff. This week I wanted to pick up a physics one written by Lewin Day, Detecting Neutrinos, the slippery ghost particles that don't want to interact. And boy, that basically sums it up with neutrinos. You may not know it, but there are like millions of neutrinos passing through you right now.
Yeah.
Does it itch a little when I say that?
Yeah.
Oh, sorry, 100 trillion neutrinos every second. Okay, so that's a lot of them. But the deal with neutrinos is that they are super light, super fast, and just don't interact with everything. They pass through the empty spaces between your atoms, and they do it unscathed. And so if you want to see these things, how do you do it? And the first neutrino experiment actually goes back to 1956, which is really interesting. The modern ones and the kind of big science ones use basically a super huge tank of ultra pure water. Why water? Because when one of the like ultra lucky neutrinos finally does interact with something, you get Cherenkov radiation. It's that actually really pretty blue glow that maybe you've seen in videos of people putting control rods from nuclear power plants in water. Basically, what's happening is that the neutrino, in slowing down, loses some of its energy, and that's emitted as light. And so you've got a really super gigantic tub of water and tiny little blue flashes of light going off as one of the lucky neutrinos interacts. How do you detect it? The answer is with photomultiplier tubes, which are by themselves a really awesome device. They're like, well, I guess they are a special kind of vacuum tube, and they go back to the 1950s, and they're kind of the coolest of all possible vacuum tubes. You paint the surface with something that exhibits the photoelectric effect. So the photon hits it and it gives off an electron. And then the rest of the photomultiplier tube is the multiplier part, where there's a one after another cascade of ever more highly charged plates. And so the one electron hits the first plate, and because it's charged up at 100 volts, like 5 electrons get given off of that one. They get pulled into the next plate, which is charged to like 200 volts, and then 25 come off of that one. And this way, by going through like 9 stages or something, or 12, depending on how fancy your photomultiplier tube is, you get something like 5 or 10 to the 9 or 12th power magnification at the end. And so you can actually easily measure one photon coming in converted to one electron, and then it just gets avalanched up to so much that you can actually plug something into it and see it go ping on a voltage meter. Coolest thing ever. And so what I really love about these neutrino detectors is that it's a ridiculously hard problem to detect neutrinos because it's an incredibly small signal. On the other hand, in theory anyway, it's a super easy solution. You just get a big enough tank of water, use ultra pure water so that you can see through it really well, and then a million bazillion of these photomultiplier tubes, and you completely surround it. And then you can tell where it's coming in. And that's the principle behind the Japanese Super Kamiokande. The problem, of course, is that theory and practice are two entirely different things. And making one of these in real life, even though I can describe it to you here in this podcast for free in like 30 seconds, making one of these in real life involves all of these terrifyingly difficult engineering problems, millions and millions and millions of dollars, the work of hundreds of scientists in making the thing work. You know, they're buried underground so they don't get any interference, et cetera, et cetera. I don't know. They're just these really neat detectors. Like, it's really easy for me to say this is a neutrino detector. And on the other hand, just the scale and the signal to noise ratio of it all just makes it nearly impossible. It's a miracle that it could be done at all, even though it sounds simple on paper. And that like stark contrast between theoretical physics and experimental physics, between theory and practice, I really love it because, you know, that just hits that point right on home. And before we leave, by far the coolest of the new neutrino detectors is Dune. And this one has a 2-dimensional grid array, so it can see not just that there's a neutrino coming in, but they kind of leave a trail of electrons in their wake. This one detects the path that the neutrino took as it went through the chamber. I think they're using liquid argon, it says, because it's denser than liquid water. The point is that this one is buried under the ground in South Dakota and is detecting neutrinos emitted by the Fermilab neutrino source, which is down by Chicago in Illinois. And so they're shooting these neutrinos through whatever in the ground. You know, it's all underground. So they're shooting these neutrinos from Illinois clear up to South Dakota, where they're going to see them on this Dune detector. And the Fermilab folks describe their neutrino source as being like a super bright spotlight for neutrinos. It's just like sending out this like ridiculously concentrated neutrino beam. And of course, because they just go through everything, it doesn't matter at all. And it just passes right through the Earth, clear up to Or at least when they get Dune online, they'll find out if it goes clear up to South Dakota. And of course it will. That's a crazy experiment. Physics is weird.
For my can't miss article, I chose Tom's John Con 0 by 0, a strong start with a bright future. Now, I've never heard of John, Smurf, or Dakine as regional slang, but in the Midwest we have ope.
Oh,
Like if you run into somebody accidentally, ope. Yeah. But apparently John is just anything that you je ne sais quoi that you don't have a name for. Yeah, so that's what that means. And it was very small. It's the first one. They wanted to keep it small. And also they only had 100 days between conceiving the thing and actually holding it, which is pretty amazing, especially for a first one. It sounds like Tom had a great time though, and between the environment and the talks and the show and tell part that was happening in the hangout room, it sounds like it was really, really cool. Part of it was there was a talk about payphones, and in the hangout room there were a bunch of payphones set up on a network together, and there were other ones around the campus that you could call, and you could also dial up the weather or to hear some music if you wanted to. So I need to check out that talk. It's weird that there are adults out there who have never used a payphone, isn't it? Isn't that weird? Am I just old?
I suppose. My son has even used a payphone. They're super slow in phasing them out here. It's actually gone now. But when he was 5, a mere 4 and a bit years ago, there was a payphone by the post office, and he played with it. I bet he can't remember it. I wonder. I'll have to ask him if he remembers playing with the payphone when he was a little kid. It's gone now.
Oh.
Anyway, I love the PhilTel project and kind of all of the crazy phone freakers who are still keeping old phone tech alive.
Oh, yeah.
Because it is actually really interesting tech just on its own, and has a whole bunch of fun challenges to rig up networks. And plus then you get to do something cool with it.
Yeah. So one of the things they had going on is in the hangout room, people brought hardware to show off, and some of it was listed on the site and some of it was just surprise potluck. One of the ones they knew about in advance was the Ferris War Drive, and that's a war driving rig, which that means driving around looking for Wi-Fi networks.
Right.
It comes from war games, war dialing, and there's all kinds of war X, like if you're on a train, it's war railing and war cycling and war walking or something like that. And everyone was very well behaved. The school was very happy with them.
All right.
But they had a very loud teletype going on and they had to shut it down.
That's how you know it's a party, when your teletype is so loud that you have to shut it down. Oh my God. Ferris War Drive, 16 wireless interfaces.
Yeah.
That's ridiculous. I guess it has to get all the Wi-Fis at once.
All the Wi-Fis.
Yeah, well, I think it's awesome to see small hacker cons popping up. I guess this one is related to the previous East Coast HackerCon that Tom went to and totally loved, which was called Whopper. So more war games references. But then I guess that faded out for whatever reason. But then they decided to do another one. So good for them. I like to see them. Hackers returning unscathed from the pandemic and all that, right? Like, it's important for people to get back out and show each other their freaky, freaky ways.
PH freaky and otherwise.
PH freaky was the one I meant.
Oh, okay.
Well, but yeah, fair enough. Yeah, we talked about it last episode, but SuperCon was super fun. I'm still both a little bit sleep deprived, but still on my post SuperCon high. It was such a great time.
It sounds like you didn't get sick.
I didn't get sick.
Nice.
Yoo-hoo.
Very good.
I haven't heard anyone talk about a large sickness spread around. I think people were all pretty, I don't know. Again, it's one of those pandemic things. People were pretty careful about, even just regular sicknesses. And so nobody was up in everybody's face. And
That's good.
I don't know. I mean, you used to always get colds when you go to a hacker convention / even a small one like SuperCon. Maybe a few people would walk away with colds just because, people come with colds and share them.
Yeah.
But I
Well,
haven't
they don't,
heard
you know,
much.
they don't know how they have it. It's possible. Or they picked it up on the plane on the way there.
Oh yeah, travel on the way. Yeah, no, it's a magnet. But as far as I know, I haven't heard anybody get sick. So
Good.
heard more about people complaining about their heavy luggage on the way home, full
Oh.
of swag and stickers, and a bunch of people went to Apex and bought a lot of electro junk and
Nice.
stuff like that. So yeah, can't complain about that. That wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you want to check out the links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, tip us, tips@hackaday.com. And until next week,
Keep on hacking.
beep dee dee, no more tangents, all podcasting.
Okay. I promise.
A promise I will certainly break. That's funny. You have a very angry bird outside your house.
Hey, go away! Go away! All math is cool, but it doesn't like me.
Math used to like me more. It gives me a headache, though. Go easy on them. They only cost you $1. And they're made with fake parts. Oh, the world we live in. Yeah, let's make up a thing and do the thing.
All right.
Oh, hit stop.
Ooh.